Approximately 2/3 of these turbines that are installed across the globe were delivered more than 10 years ago. With the design lifespan of a turbine being 20 years, owners and operators are reaching a critical stage in the turbine life cycle as that install base is aging. With funding options and frankly permitting options being limited, the question is being asked is how do we support those operations and meet energy production needs, all while extending the life of the existing install base beyond that initial life expectancy. So electricity consumption demand is going to continue to grow. I think we've covered that here a little bit earlier. And with that demand being driven by semiconductor, battery manufacturing, artificial intelligence, and electrification of transportation, the production of renewable energy must continue to operate reliably. On the next slide, we see that without proper maintenance, turbine performance is going to degrade over time, and that's going to result in reduced energy output and increased unplanned downtime. Modernizing systems enhances performance, enables compliance with an increasingly stringent grid code while boosting overall efficiency. As the turbines age and approach their end of life, the cost and lead time for replacement parts on those systems is going to rise significantly. It's been trending 10% more year over year. And that's just the beginning of the challenges that are faced by owners and operators. Grid codes changing every year, becoming much more strict. And with each change made to align to those grid codes, the performance requirements of the equipment installed raise that bar on efficiency and stability. Cybersecurity is also a universal concern, but specifically in energy production, a single breach can cause significant damage to a turbine and can lead to serious disruptions, putting the entire operation at risk. So it doesn't really matter where that farm is. The barriers for repower are similar across the globe, with turbines being 10 to 20 years old. Supply chain limitations on older technology increase the cost of maintaining older equipment and drive the need to repower to more current technology to keep those operations running.
With modernizing the electrical equipments like converter and generator in the age of 10 to 15 years, one can achieve two goals. Number one, increase the performances. And number two, double the lifetime of those components and to reach 35 to 40 years in operation. And with this, what we can say that, but we know that the economic progress of the wind farms does not happen. The economic progress of wind parks is made by working together between wind farm owners and component suppliers. And we are happy here to introduce ABB solutions to improve the performance in the wind parks. Now, speaking about wind generators. There we will have two types of solutions. Number one, workshop refurbishment, and number two, replacement and ABB generator on stock. On the next slide, what we see is that ABB workshop refurbishment for the generator brings the new stator that increase annual energy production up to 5%, increase reliability, and in the last 10 years, all the generators that ABB upgraded in the workshop reported zero magnetic wedge failures. This was in past one of the most common failure modes up to 2014. And now, whenever we do the upgrades, we have zero reported magnet slot wedges problem. And in the next slide, what we have also is possibility to have generators on the stock to ensure, number one, fast delivery, and number two, tower ready, with improved reliability and increased equipment lifetime.
So we spoke about the generators, gearboxes, and blades being top of the list in failures of a wind turbine. With the generators, the magnetic slot wedge is a common failure point, with some sources stating that it can be more than 12% of the failures in generators with that design. In the case of the upgraded stator, customers can remove that failure point in the stator. By upgrading with these stators, customers have reported, like Ketchum said, 0 failures since 2014. That's 0. So with a new stator, customers are now producing more effectively and reducing their failures by that 12%. That doubled the lifetime of the unit, or potentially longer. And with a Class H insulation, the generators are designed to withstand repetitive pulse voltage from the converter. Eliminating that magnetic wedge avoids the long downtime needed to swap out the generator in the field and keep the system producing steadily and reliably for the customer.